In this section, we're going to take a look at how we can perform operations on functions. And essentially, what this means is that we're going to be adding, subtracting, dividing, and multiplying functions. It's actually fairly easy to do this for the most part. So if you want to just add two functions together, f plus g of x is the sum of the two functions, similar with the difference of two functions. If we want to find the product of two functions, fg of x, that's going to be multiplying two functions. And then finally, quotient is dividing the two functions together. Okay, and of course, the domain is where the denominator cannot be equal to 0 for this. Now, the domain of the resultant of any of the four operations above is the domain of the values found in both f and g. So when we do this, what we're going to do is we're going to take a look at the domains of both of the functions prior to the operations and then also after the operations. And we're going to determine whether or not there has to be some sort of resulting there might be something that happens to where it looks like that a value might be in the domain, but because it's not in the original of the two functions, then it can't be in the domain of the resultant. So a few examples of this. So let's say we have a function f of x is 7 minus 4x, and then g is x squared plus 3x plus 2. And we're going to go ahead and start by finding each of these sorts of addition, subtraction, multiplication, division. And then we're going to go ahead and try to find what the domains are for those. And we're going to put it in interval notation. So notice that in both of these functions, okay, there's no denominator and there's no square roots or no fourth roots. So no denominator, and there are no even power radicals. All right. And so what that means is that the domain is going to be all reals to start. So basically what that means is that there's no domain restriction to begin with. So that now that doesn't mean at the end there won't be a domain restriction, but we have to make sure that that applies to all of or to each of the resultant functions. So when we add two functions, this is just going to be equal to f at x plus g at x, which is going to be the same as 7 minus 4x plus x squared plus 3x plus 2. And this is just merely combining like terms. So looking at the highest power variable, we have an x squared. And then we have a negative 4 and a positive 3. So that's going to be a negative x. And then finally, we have a 7 and a 2. 7 plus 2 is usually 9. All right. So this is the resulting function. And to find the domain of that, we just look at this. And it has no even power roots. And then also it doesn't have any denominators. And so the domain of this function would be x is an element of the real numbers, or from negative infinity to positive infinity. All right, so let me write that in there. All right. The next one we have is f minus g. All right, and so we already know that the domains of the function start with having all real numbers. And so f minus g of x is the same as f of x minus g of x. And so that's going to be equal to 7 minus 4x minus x squared plus 3x plus 2. Sometimes it's helpful to distribute the negative to the three terms that are inside the parentheses, or however many terms there are, and then combine like terms. So 7 minus 4x minus x squared minus 3x minus 2. And now we can combine like terms. There's nothing else like negative x squared. So we have a negative x squared. We have a negative 4 and a negative 3. That's going to be a negative 7x. And then finally, we have 7 minus 2, which is going to be plus 5. And once again, we notice that there are no denominators, there are no even power roots. And once again, that means that the domain is going to be all real numbers. And so our domain is going to be x as an element of negative infinity to positive infinity. Right? We're going to multiply two functions. Okay, so that's going to be the same as f of x times g of x, or 7 minus 4x. And now we're going to multiply it by the other function, which was x squared plus 3x plus 2. Right? And so now when we multiply, we're going to basically have a FOIL problem that's a little bit bigger than a FOIL. Right? So we have a 7. We're going to multiply by all three of those terms. and then we have a negative 4x. So we're going to multiply by all those terms. So let's start with the 7. 7 minus x squared, or 7 times x squared is going to be 7x squared. 7 times 3x, so we're going here, that's going to be 21x. And then 7 times 2 is 14. Negative 4x times x squared is negative 4x cubed. Negative 4 times 3, negative 4x times 3x is a negative 12x squared. And then negative 4 times 2, 4x times 2 is a negative 8x. And of course, we're going to combine like terms. So notice that we start with the highest power. There's nothing else like the cubic term. So that's going to be negative 4x cubed. We have a 7 and a negative 12x squared. So it's a minus 5x squared. We have 21 and negative 8. So 21 minus 8 is going to be 13x. And then we just bring down that 14 as it has no other constant to combine with it. All right, so this is f times g. Once again, no denominator, no even power radical. So we're going to say x is an element from negative infinity to positive infinity. Okay. All right. Now, the last of these does have a domain restriction because we're going to divide. All right. And so remember, we have 7 minus 4x. And by the way, this is the same as f of x divided by g of x. And so we're going to have 7 minus 4x. And then we're going to divide that by the x squared plus 3x plus 2. Okay, so x squared plus 3x plus 2. Now, usually what we'd like to do is we'd like to see if we can simplify this. And so what we're going to do is we're going to factor the denominator. And this one's a pretty easy factorization because we know 2 is only 2 times 1. Everything's positive. And then to get x squared, that's x times x. All right. Notice that nothing can cancel. Okay, so if there were a common factor of like x plus 2 or x plus 1 in the numerator, then we would cancel. But this is about as good as we can get with this. Now, the domain restriction, because we have a denominator, we say that x plus 2, x plus 1 cannot be equal to 0. And so what that means to us is that x plus 2 cannot be equal to 0, and then x plus 1 cannot be equal to 0. And so that means that x cannot be equal to negative 2, and also x cannot be equal to negative 1. If we draw that on a number line for our domain, we have negative 2, negative 1, 0, and x cannot be equal to those values. All right, so we have an open circle there, but x can be anything else in the domain. All right, let me erase this. Unfortunately, that was pretty poor inside of there, so let me try to redraw that a little better. All right, but so we can have in between here, we can't have at 1. And so basically, our interval notation is going to be x is an element of negative infinity up to negative 2. Then it's going to go from negative 2 to negative 1. So we see that gap there. And then from negative 1 to infinity. All right, so that's going to be our domain for this. So hopefully this illustrates how we can go through and add, subtract, multiply, divide functions, but then also it illustrates how to go through and get the domains of those functions. In subsequent videos, we're going to look at ones that are going to have domain restrictions initially. All right, and so when we get to those, we might have to do a little bit more work.